Since 1964, we have had this idea proposed by Englert, Brout and Higgs that empty space is like a medium, and as particles travel through this medium, some of them interact with it, some of them don't interact with it. The ones that do interact with this medium, they acquire masses, and the ones that pass through it without interacting, those are massless particles. Let me give you an analogy. Imagine an infinite field of snow extending throughout all of space. Flat, featureless, going in all directions. Maybe the middle of Siberia. Now imagine that you're trying to cross this field of snow. So maybe you're a skier and you skim across the top. That's like a particle that does not interact with the Higgs field. It doesn't sink into the snow. It goes very fast. That's like a particle with no mass traveling at the speed of light. But maybe you've only got snowshoes. In that case, you sink into the Higgs snow field. You get less speed than the skier, less than the speed of light. That's like a particle with mass because you are connecting, interacting with that Higgs snow field. And then finally, if you've just got boots on, then you sink deeply into the snow. You go very, very slowly, and that's like a particle with a big mass. So think of this Higgs field as being like this universal field of snow. Now, where does the Higgs boson come in? Well, we all know what snow is made of, right? It's made out of snowflakes. In the same way, this universal Higgs snow field is made up out of little quanta. Those quanta are like snowflakes. That's what we call the Higgs boson. The Higgs boson has this job of giving masses to all the other elementary particles. If you look at the basic equations of the Standard Model, as written on my T-shirt, they're very symmetric. The way in which all the different particles appear is the same. At least on the top two lines, there's nothing to distinguish particles which have different masses, for example. But this symmetry has to be broken. Electrons are lighter than muons. The top quark is much heavier than the quarks that make up everyday nuclei. So the top two lines, the symmetric lines, cannot be all there is. There has to be something to discriminate, distinguish between the different types of particle. And that's the job of the Higgs boson. That's the job of the two bottom lines. Depending on how those different types of quark, or the electron and the muon, depending on how they connect to that Higgs field, that Higgs boson, we believe they get different masses. The symmetry between these particles is broken.